So, good morning, students. So, today we will discuss about the Coulomb's law. So, Coulomb's law is basically a force of interaction between the two charges. तो ये कैसे काम करता है और देखते हैं. सो मान लीजिए हमारे पास दो चार्जेस है. वन इज द Q1 and another one is the Q2. Both the charges are separated at a distance of r, and they have the medium between them is air according to Coulomb. The Coulomb says that the force of interaction, that might be the repulsion force or it might be the attraction force. The force of interaction F between the two forces is directly proportional to the product of the two charges, that is the magnitudes, and inversely the square of the distance between the two charges. अगर हम इसको combine करेंगे so इस have the values Q1 Q2 divided by r square. So from here you can have the value F. proportional sign को उठाएंगे, लिखेंगे F is equal to a constant K, then Q1 then Q2 divided by r square. So this K is called a proportionality constant, and this is called the Coulomb's constant. It is the Coulomb's constant, right? And the value of K is 1 by 4 pi epsilon naught, and this is called epsilon, and this is also called the permittivity. It is the permittivity of free space. परमिटिविटी क्या होता है? परमिटिविटी मतलब लाइन्स ऑफ फोर्स को पास करने के लिए मीडियम जो परमिट देता है उसको बोलते हैं परमिटिविटी. ठीक है, तो अभी कूलम्ब्स फोर्स का वैल्यू कितना हो गया? सो द कूलम्ब्स फोर्स इज नाउ बी इक्विवेलेंट टू F इज इक्विवेलेंट टू 1 by 4 pi epsilon naught Q1 Q2 divided by r square. So this is the magnitude of the Coulomb's force. ठीक है. So now we go for the values. So how to get the values? So this 1 by 4 pi epsilon naught is equivalent to 1 by 4 pi into the value of epsilon naught is 8.85 into 10 to the power minus 12 unit. So अगर इसको multiply करते हैं so you can have the values 9 into 10 to the power 9. So the Coulomb's force is having a value of 9 into 10 to the power 9 Q1 Q2 divided by r square. So this is the final expression for the Coulomb's force, and this is a scalar form. It is the scalar form. So if you want to find the vector form of the Coulomb's law, if you go for the vector form, so you can have the value F is a vector and the value is 1 by 4 pi epsilon naught, then Q1 Q2 by r square, and as a vector it is a direction r cap. So from here you can have the value F vector is equivalent to 1 by 4 pi epsilon naught Q1 Q2 divided by r square, and the vector r cap can be written as the r vector divided by r magnitude. So the vector form of Coulomb's law F is equivalent to K Q1 Q2 divided by r cube and a r vector. So this is the vector form of Coulomb's force, right? So now if the medium between the two charges is replaced by other medium, then what should be the Coulomb's law? So let's think that if the two charges are there and they have the medium between them is water, then the Coulomb's force if any other medium is equivalent to 1 by 4 pi epsilon naught epsilon r, then the same charges q1 q2 divided by r square, and this epsilon r is the relative permittivity. Relative permittivity epsilon r means permittivity of the medium to permittivity of the free space, right? So this is the relative permittivity, and it has the no unit. Relative permittivity for water, the value is 80. Relative permittivity for metal, the value is infinity. Relative permittivity for air, the value is 1. So if you use water, then you can have the value if water is equivalent to 1 by 4 pi epsilon naught, and for the water the relative permittivity value is 80, so it is q1 q2 divided by r square. So for here you can have the value 180 and the bracketed term 1 by 4 pi epsilon naught q1 q2 divided by r square. So you can write this as 1 by 80 bracketed term, and this the value is FAR. So from here we have a conclusion that if water is equivalent to FAR divided by F80, that means if AR is replaced by water, the force decreased by 80 times. So for that reason the water is called a solvent. Water is called as a solvent, right? So this is all about your Coulomb's law, and for more we can discuss later. Thank you.